Problem 1, we're asked to sketch some of our cylindrical and quadric surfaces. This first one is a plane along the x-axis out here at 2. And so you do your best to draw something that looks like a plane along the x-axis. This one is a saddle, and so you can see that z equal x squared is what the first part of this is. That means the saddle is going this way. That's the seat of the saddle, and then cover up that, z equal minus y squared. That's the values going down this way. So that's the parts that are hanging off the saddle. Make the sides of the saddle. Let's go over here. This is a cone just based on the form, and it's going along the z-axis because the z is the one over here by itself. So I'll just draw two straight lines, connect the ends with circles. This is an elliptic paraboloid that's going along the z-axis. So something like that. Nothing to label on any of these last three that we just did. This one is a hyperboloid of one sheet along the x-axis. So you draw a hyperbola along the x-axis, and then you connect the ends with circles. This one you can label. This sort of middle circle is going to cross at z equal a and y, which is kind of shown in a weird way, but y equal b. I should have made it go across there. But anyway, just a rough sketch, and this is a ellipsoid. So you draw something like a circle, and then maybe another circle going around that way. And if you want, you could even put a third one in, but that's probably enough to see that it's an ellipsoid. It's going A on the x-axis, B on the y-axis, and C on the z-axis. This is a hyperboloid of two sheets, and it's going to be in the y direction. So it's going to start here and go this way with a hyperbola, and then put circles on the end. And over here going this way with the other half of the hyperbola. And these are at minus a and a. And then finally, this is z equal y squared. So that says as I plug in y coordinates, which is this axis, I'm going to be generating z's. So make a parabola. But then the x is missing, so I'll stretch it in the x direction. So, and this goes on that infinitely in both directions. So it's your cylindrical graph.